Here are the solutions. I hope you tried it first, or if you need some support, here we go. The rational zero theorem, just create a list. So if I look here, the last number, what are all the numbers? They don't have to be in order, so maybe it's easier to go, 1 times 27, or 3 times 9, and that's everything. Now, what makes this one different is the first number is a 3. That's going to create fractions, denominator. Now, when you divide by 1, it's not going to create a fraction. So all the numbers that go into 20, we'll start there. So 1 and 20, notice positive and negative, 2 and 10, 4 and 5. Then I'm going to do the same thing I just did. So picture there to be a denominator dividing by 1, but it doesn't change the thing. Is I got to do the same thing with 3. So divide by 3. It's going to go across the box here. Divide by 3. Divide by 3, divide by 3, it's going to go underneath here, divide by 3, and divide by 3. So we have our list, which is the last number, and then we also have to divide by 3 because the numbers that go into 3 even there are 1 and 3. So the first number creates the denominator. If the first number is 1, then the denominator of 1, I don't need it. But if it's a number other than 1, it creates fractions. And there it is. All right, so here we need to Descartes rule of signs. We didn't do this one. So you know what? I'm going to say, let's not do that. Because we didn't go over it. So even though I said 1 through 11, don't do 3 and 4. I'm going to change it in Google Classroom right now. All right, number 5. This is what I want to practice. Can we create a list? So all the numbers that go into 30. So I'm just going to go one at a time here of what I remember, and hopefully I remember them all. It's a big list. So did you get all of those numbers? All right, so there are 3 numbers defined on this list. I actually know what the answers are, so I'm not going to guess in the video. But if you put 2 as one of them, so I'm going to use that one. Now make sure you have a 0 here, because we're missing an x squared. Did 2 work? Maybe 2 didn't work. What did I do wrong? 1, 0, negative 19. I think I did something wrong. 1, or why did that become a 2? So drop the 1 down. Let's do it right. I knew it was supposed to work. 4, this should be negative 15. All right, now we're going. And that's negative 30, that's a 0. So what you're left with is 1x squared plus 2x minus 15, and then factor that. And so those two numbers are 5 and negative 3. Now, the factoring part, that's this part, we know positive 5, I know minus 3, those are factors. The 2 is actually a 0, so the opposite sign is a factor. X plus 5, the opposite. X subtract 3, the opposite. And we found the zeros in the factors. All right, number 6. Now, number 6, I can actually factor. I don't need a list. So I'm going to factor out 9x squared. That's x plus 7. I'm going to factor out negative 16, believe it or not. That's again x plus 7. So one factor is x plus 7, make it equal to 0. The other factor is x squared subtract 16, make it equal to 0. So we don't need to create a list and divide if we can factor. So I factored it, each factor equal to 0. I'm going to solve it. So I'm going to subtract 7. That's a 0. Here, I am going to add 16 and divide by 9. Now, when I square root this, the answer is going to be positive and negative, and I'm going to square root it. So square root of 16 and the square root of 9. Now, for the factorization, I have to think just a little bit. So this one's easy, that's x plus 7. But for this one, when I have this, think of it like this, I need to slide the denominator. So instead of writing this and this, because one's positive and one negative. Slide the denominator in front, and you would get 3x plus 4 and 3x minus 4. And now this would match this question. It's a little bit tricky. Number 7. So number 7, I'm going to, first thing I notice is there's an x to factor out. So I'm going to factor out an x. Now, this is not factorable. So I'm going to take that last number 12. So already I know just x by itself, 0 is a 0, and x is a factor. So I got that, or x minus 0. 12, I'm going to start there to create my list. Now, there are fractions too. And so if you divide by 2, 2 divided by 2 is 1. 4 divided by 2 is 2. 6 divided by 2 is 3. 12 divided by 2 is 6. So those are all the ones. So those are the only two fractions. Then we're going to divide and see which one works. So I'm going to help you. You should try to see if you can find it. So there's a couple numbers, but negative 2 is one that works. I did it right this time. I'm proud of myself. And I have 2x squared minus 13x plus 6. Let's do this. Some of you forgot how to do this. We need to do this. Take the first number times the last number. And then find the two numbers that fit. Then we're not done. So it's x minus 1 and x minus 12. I have to divide by 2. So when I divide by 2, as a factor, I'm going to slide the denominator. So that's 2x minus 1. Now 12 divided by 2, no sliding, it's just 6. Then for the zeros, it's the opposite. So that's going to be positive 1/2 and positive 6. And those are all the zeros. Oh, I forgot one. Negative 2. Let's get that on the list. Negative 2, which is x plus 2. Now I have them all. All right, number 8. Again, not factorable, but the list is so small, which I like. So it's just the last number. So it's just positive, negative 1, and 3. Just double checking to make sure there's no zeros, which there's not. Positive 1 doesn't work. I'm going to try negative 1. And that works. I need to do it again. So, well, no. I can actually write that out. So let's go x to the 3 plus 1x squared minus 3x minus 3. This one actually is factorable now. So if you factor out an x squared, and if you factor out a negative 3, we can factor this. So we have a factor here. Let's start here. So negative 1 is a 0. Let's start there. And that means x plus 1. Here I see x plus 1 again as a factor. So that means it's squared. It showed up twice. And then what I'm left with here is x squared minus 3. I'm going to make it equal to 0. I'm going to write that down. X squared subtract 3. And then I'm going to solve it. So I'm going to add 3. And when I square root it, it's going to be plus or minus. It's going to be irrational. So we have a 0 at negative 1, and it's repeated, and plus and minus root 3, which is irrational. So rational and irrational. All right, number 9. Oh, we have a 5 in front. So we have plus and minus, or is this one? You know what? This one's factorable, I think. Yeah. So I don't need to create a list. So I'm looking at it and go, if I multiply it by 18, they're going to match. So I feel good about it. So I'm going to factor out an x squared. That's 5x plus 2. I'm going to factor out negative 18, and that's going to give me 5x plus 2. So one factor is 5x plus 2. The other factor is x squared take away 18. And then I solve it. I'm going to subtract 2. I'm going to divide by 5. That's a 0. I'm going to add 18 and square root. And I'm not going to simplify it, but it is irrational. Positive and negative root 18. So if I said the factors here, you would say 5x plus 2 and x squared subtract 18. And that's factored. All right, this one's definitely factorable, a trinomial. So the two numbers are negative 5 and 4. So the two equations are going to be x squared minus 5 equals 0 and x squared plus 4 equals 0. And then solve it. So we're going to add 5, and when I square root, it's going to be positive and negative and irrational. I'm going to subtract 4. When I square root, it's positive and negative, but it's imaginary because when you square root a negative number, it needs that I. So this is positive and negative root 5 and positive and negative 2i. And then the factoring are these, x squared subtract 5 and x squared plus 4. All right, last one. Turn the page. Number 11. All right, this one is not factorable. Boo. So I can't multiply and have them match. So we have a list to do with 51. That's 3, and I think those are all of them. Let me double check. So I think 3, 17, and 51. And then which one works? So it's not 1 or negative 1. I think it's negative 3 that works. What did I do wrong? 24 take away 7 is 17. That's what I did wrong. 17. That's negative 51. That's 0. So I have x squared minus 8x plus 17. All right. So I'm going to make it equal to 0. Normally I would draw a diamond, right? X, but this is not factorable. There's no two numbers that multiply to 17 and add to 8. So I'm going to complete the square, which you need help with. So I'm going to take a, b, c. I'm going to take the b value, and I'm going to divide by 2 and square and come up with a magic number. Oh, that's not the magic. Yeah. So negative 4 squared, which is equal to 16. So that number 16 is going to be added to both sides. So I'm going to add it to the left, and I'm going to add it to the right. Now, this first parentheses now is factorable. So like what two numbers multiply to 16 and add to negative 8? That's negative 4 and negative 4. So I write that as negative 4 squared. Then I'm going to subtract 17. When I subtract 17, I get negative 1. I'm going to square root this. So that means it's going to be plus and minus. And the square root of negative 1 is I. It's imaginary. It's 1i. And then I'm going to add 4. That's just going to go in front of I. So I'm going to add 4, so it's positive 4 on the right side. It just goes in front. And those are my zeros. So my first 0 I found, which is rational, is negative 3. And then 2 more were 4 plus I and 4 subtract I. The factoring then would be, if it's negative 3, it would be x plus 3. And then it's x squared subtract 8x plus 17. That's not factorable, more factorable, so that's just factored as that equation's going to be. All right, Mr. G Math, over and out. I hope that helped. Until next time.